Hey guys, so we are starting 2.4, which is called the Library of Functions. Now, the first week of school, you were given a big, huge packet, right, of many parent functions. 2.4 is just a continuation of that. So we will start with the greatest integer function. So an example of the greatest integer function is going to be, I'm going to give you an example. F of x is, in your book, it uses int x, okay? Then other books uses f of x equals bracket x, okay? So these two are exactly the same, except that some books will write int x, which is your book actually use int x. Now, if I were to make a worksheet, then I normally typed it as a bracket x. So I just want you to make sure you know what it means, okay? So the greatest integer x, so let's give you some examples of what that is. So when I pick values, let's say I'm going to pick 0, okay? Well, greatest integer x, okay? To get it out of the bracket, you have to round down. Again, you need to round down, okay? But if it's already an integer, hence integer, okay? So your answers always come out to be an integer. So if it's already an integer, you don't have to round. So I'm going to pick a value, for example, 0.3. Then I'm going to plug it in my bracket. To get it out of the bracket, you need to round it down to the nearest integer. So rounding it down is still 0. How about if I pick 0.5? Okay, this is just an example of what it really means. Again, I need to round it down to the nearest integer. So that's going to be 0. Okay, then I'm going to pick 0.9999. Okay, that's super close to 1. And most math rules that say that will round down to that would normally round to 1 because it's so close, but not when you're working with the greatest integer function. To get it out of the bracket, you again round down, even though your brain tells you that's crazy, but that's the way it is. Now, then when would you get to the next integer? You're going to get to the next integer when you enter in 1. So 1, because it's already an integer, you don't have to round down anymore, okay? But, I mean, so that's really what that is. So these two values here, when you enter in an integer, then you don't have to round anymore, okay? Because it's already an integer. So what am I going to do with this? I'm going to sort of, make it, let's rescale this, okay? I'm going to make every 3 tick marks a 1, okay? So anytime you change your scaling, you have to label it. If you don't want to, then you don't have to. Oops, I meant to go 2 and then 3, okay? So that's that. So now the spots that we didn't round, these are the ones that you're going to have closed circle, okay? Closed circle. So I'm going to put a closed circle right there when x is 0, y is 0. Now when x is 1, that's another closed circle, okay? So 1, 1. Well, what does that mean? Well, look at this, right? Check this out. See this right here? This right here, when x is 0.3, it's still at 0. Whoa, right there, right? When x 0.5, it's still at 0. When x 0.99999, it's still at 0. So any value you pick, okay, between 0 and 1, not including 1 and not including 0, that will always be here at 0, actually including 0 as well. So any value you pick between 0 and 1, not including 1, it will be 0. So that's why we're shading this in. Now, until I pick 1, that's going to be open circle at 1. Because what's happening? It's at 1, it's an actual value, okay? You have an output of 1, which is an integer. So you're not rounding anymore. So that's why there's a line from 0 to 1 and then open circle at 1. Because at 1, the output is up at 1. Same thing, right? So what if I pick like 1.5? Well, 1.5, I need to round it down. 1.5, plug it in my absolute value symbol. I'm sorry, not absolute value, greatest integer symbol. I need to round it down 1. 1.5 is here, right? But I still need to make a dot at 1, okay? I'm going to make a dot at 1 until when? Until I hit 2. Greatest integer value of 2 is now, because 2 is an integer, I don't have to round down. I can keep it. So I'm going to have everything is going to be 1 until I get to 2, okay? So at 2, I have 2. So that's when I go to 2 and I make a closed circle. And if you see the pattern, this is actually called another book, or sometimes this is also called the step function, okay? So AKA step function, because the graph looks like steps or stairs, okay? So the step is 1 unit long and 1 unit high. And for this one, the closed circle, there's always an open circle right below it. So I'm going to have a step 1 unit long all the way, and then there's an open circle over here, okay? Unit 2, can you see that I labeled this wrong? I wrote 1, 2, and 2, so that's actually 3. Sorry, I'm sick and I can't think straight. Okay, so now when I get to 3, because 3 is already an integer, I don't need to round down. I can just write 3. So I'm going to go up and make a dot at 3. See that right there? So if I want to keep on going, my step will be 1 unit long and go all the way. So what you need to do is understand that, hey, the step will always be uniform, okay, on this one, and the pattern is going to be the same. Underneath each open circle will always be a closed circle. I'm just going to put in some more tick marks so it's easy for me to graph. So let me see if my tick marks are right, because I made every 3 tick marks as a unit, so I want to make sure I'm okay. So I'm going to put an open circle here, okay? Then I'm going to go 1 unit to the right and make a closed circle. Because I have a closed circle, I'm going to go underneath it, make an open circle, go to the right, make a closed circle. Underneath it, I'm going to have an open circle, to the right, and closed circle. So that's what a step function looks like. Now, what is the domain? The domain is going to be all reals, or I can also write it as an interval notation, okay, negative infinity to infinity. The range, okay, so now the range is going to be interesting because look, I don't have anything in between there. You see that? None of that is there. So, but the range is going to be at 3, at 2, at 1, at 0, at -1, at -2, and -3. So those are called integers, okay? So the range is just all integers. Now you can spell it out, or you can use the Z to represent integers, okay? X-intercept, there are a lot of X-intercept. So the X-intercept is here, okay, and it starts at 0. It's an interval notation, okay, interval, okay. X-interval is going to start at 0, including 0, and will go all the way to 1, okay, and not including 1, okay. Because there's just too many to list out. I can't really say, X-intercept is 0, 0.1, 0.2, 0.3. I can sit here and list out infinitely many. Y-intercept, there's only 1, 0, 0. Okay, so that's not an interval, that's just a point. Okay, is it even, odd, or neither? From this graph, it looks like it could be, right? It could be an odd function because it looks like it may be reflecting over the y-axis, but I'm going to prove it to you, okay? So I'm going to make a chart again. Remember, to be an odd function, we know it's definitely not even, okay? So we know that it's going to be odd. Maybe, maybe not, okay? Let's prove it. Odd question mark, okay? F of -x equals to -f of x. I'm going to let my x be, let's say, how about 2? Is that okay with you? So I'm going to do f of -2, okay? F of -2. From this graph, here's -1, Here's negative 2. F of negative 2 is actually negative 2. Okay, negative 2. Then the question mark is that, is it going to equal to negative f of a positive 2? Okay, well, let's look. Here's positive 2. Oops, just different color. Here's positive 2. I have this value. So that's negative 1 times 2. Oh my, it's the same. Okay, so those two are the same, but does it really prove? What if I pick decimals, okay? So now let x be non-integer, like let x be 2.5. Whoa, right? So let's do the same thing, f of a negative 2.5. I'm going to go look at my graph. Negative 1, negative 2, negative 2.5 is right here. Okay, so that graph tells me I get an output of negative 3. Remember, you're rounding down. Rounding down in the negative world, it's like going to the left, okay? So if I go to the left of negative 2, I would get negative 3 as an integer. Now, is that equal to, question mark, okay, negative 1 times f of a positive 2.5, okay? So, well, let's see, right? Negative 1 times, let's see what 2.5 is. 2.5 is right here, okay? When x is 2.5, output is 2. So 2, okay? Well, so it's negative 3 equals negative 2. Question mark. Well, it's not. So guess what? This is not odd and it's not even. So guess what? This is neither. So when you are plugging in a constant, make sure you plug in a few different numbers to really have an understanding of like, you know, whether it's odd or even, okay?